Hello everyone, this is Kumar. Welcome to you all to our channel TechBizZone. Today we are going to learn a new topic and it is very important for our interview room and it is very interesting and very simple. So during watching the video, you should make a note of this. Actually, this is a theoretical part. In the previous session also, we learned what is the testing and how do we perform testing and what are the other important topics related to testing, right? So now we are going to speak about types of testing and principles of testing. And this video is going to be splitted into two parts, right? Because it is very important topic for your interview room. So as a fresher or if you want to go with an experience, okay, these questions, most of the questions will be asked from this particular part. So that's why from the beginning you have to focus on this and don't skip the video. So today we are going to speak testing types. So highlights of this session we are going to see first. So in this session we are going to speak about what are the main modes of testing a software, what is manual testing, what is automation testing, why do we go for automation, principles of testing, and introduction to different types of testing. Here I would like to give you the brief summary of types of testing, and in the next coming video I would like to explain all the different types of testing in clear. Okay, so don't skip the video. From the beginning to end you have to watch. No doubt you will certainly get clear idea about types of testing and principles of testing. So without delay we are going to skip into the video. So first we wanted to know what are the main modes of testing a software. Already in the previous session we have already discussed what are the important types of testing, main types of testing. So if you don't see watch that video, I am providing that link in the below description. So first watch that video, then only you will understand the introduction to testing and as well as the brief summary of types of testing. Okay, now the same thing is being repeated in brief. Just what are the main modes of testing a software? So simply software testing will be done in two important modes. That is, one is a manual testing mode and the second one is automation testing mode. So manual, okay, every task has two importance of doing things. Okay, those are, we manually do the tasks and sometimes we automate the job. Okay, in the previous session we discussed in clear. Okay, the next, see just a simple definition for manual testing: testing some features of a software or application manually. Okay, if we perform testing manually, okay, whether the application is bug free or defect free, okay, manually we operate the system, whether the application is responding as per expected behavior or not. If we do entire application manually, entire testing manually, that is called manual testing. And the second one is automation testing. The simple definition for automation testing is automating the testing process. Okay, whatever we do the testing process manually by using some testing code, scripts, okay, and by using some tools, automation tools available like Selenium, WebDriver IO and Playwright. Okay, and by using different types of tools, if we automate the testing process to find whether all the features of the application are meeting the customer's expectations or not, that is called automation testing, friends. Okay, the next, second important question: why do we go for automation testing? This is very important. When manual testing is available, why do we go for automation testing? So there are couple of reasons why do we choose automation testing. So among those, I would like to speak few important reasons for choosing automation testing. Among them, the first important thing is continuity. That means what? In modern times, testing process will be held. Okay, not only testing process, the development of application is in continuous integration model. Okay, previously we were developing the softwares or applications like different methods we used, like a waterfall model or V model. In the later coming sessions, we are going to see all these things. Okay, that means what? When entire development process will be completed, then only the testing process is done. Okay, at the end of the development, and if there is any bugs, they are fixed and they are released to the market. That's it. One time development and one time testing will be conducted in the previous days. This is applicable for only small projects and small companies, right? But now we are working with the larger companies with the larger projects, okay, where the requirements number is very high. Okay, so that is the reason. So one time development and one time testing is not possible. So if we do follow that for the large scale companies and large projects also, the development process and the testing process will be highly expensive. So that's why if we find any defects or any bugs in the earlier days of the development, they will be fixed early, and simply we can say that we can reduce the consuming time and cost very low, and the development will be perfect. So that is called what? It is a continuation process. So based on this continuity, we have to go for automating the testing process. The second important scenario is to test repetitive test cases. So while we are in the continuity development, that is called what? CI/CD model. We are now, all the companies are using CI/CD model, continuous integration and continuous delivery model. So for this model, we have to test at the every build that repetitively test some test cases. To test these repetitive test cases, we need automation. Why? Because manually, if we repeat again and again the same test cases, the manual tester will miss some aspects of testing, right? So that's why the errors may be created during this testing process. So that's why we automate them. The third important point is, whenever we have large number of test cases to be tested at every regression. So nowadays the modern software applications are very large, and we have large number of requirements. So whenever we have the large number of requirements, so it is very common to test a large number of test cases at every regression. So for that, manual effort is not good enough. So that's why we go for automating the test cases. The next important thing is, automation testing saves time and money. In the just a few minutes back, I told you that whenever the say one-time development and one-time testing, if we go with this particular method, if the defect is found at the time of delivery, after completing the development, at the time of delivery, if the bug is raised, if the bug is found, to fix that from the beginning we have to work. So it consumes a lot of time and as well as cost. So that's why and as well as to run all the entire test cases, it takes lengthy of time. So that's why automation testing saves time and money. The next important point is productivity improvement. Whenever the fast results of automation testing will produces whether the test cases are passing or failing to the development team. So that is the reason we can easily identify the tests with a fast speed, okay, triple X speed. Then we can give that status to the development team. So the development team also responds very fastly. Then the entire work will be completed soon. The next important thing we have to consider here, that is accuracy improvement, right? We are humans, and all the humans may make error, right? But machines make less error. So that is the reason accuracy will be high when automation testing is undertaken. So that is the reason mostly the companies are going for automation testing. The next, test suite reusability. That means what? For the first release, we prepared some test suite, okay, with some test cases, and in the second release also the same test cases are being tested. So that's why the same test suite can be used for the second release, third release, fourth release also. There is no scope of rewriting the code. So that's why the once you write the code, that code can be used for every release with a little modifications, right? So that's why there is a test suite reusability available for automation testing, friends. The next important thing, that is running test 24/7 at any time, at any from anywhere. We can run the test suite and we can get the results. Just you can press run button, and we can complete our works, and we can come back within couple of minutes. We will get the test suite results, whether the test cases are passing or failing. That's it. So that's why we go for automation testing. And early bug detection, okay, this is very important feature of automation testing, right? Okay, the bugs are found at the early stages and with the double X speed. So that is why automation testing is very important for every release in modern software development. Less human resources, okay, it is very common. Why? Because if we go with manual testing, what will happen? We need a lot of resources to complete manual testing. But when we go for automation, once code is done, okay, very few testers are required to test the entire application. Okay. The next important is scalability of test cases. So for manual testing, we have to plan, we have to create, at the time of creating test plan, we have to consider number of resources and number of working hours and everything. If any resource is, okay, unexpectedly he is not able to perform the test case, okay, then the test scalability will be different. If we expect 10 days of time and with work hours of 6 hours per day, that 60 hours are required to complete the manual testing. So if any one of the resources is not good enough to test, not in good condition to test the test cases, if he is on leave, or if his health is not good, okay, because of some uncertain reasons, if he is unable to perform the test, so that scalability will be different. The scalability will be changed. The measurement, what we calculated, that calculation will go wrong. So that is the reason that may cause the entire development, that may affect entire development time and plan and release time also. So that's why but here if we go with automation, this is very less. Okay, why? Because once the suite is ready, just we can run the suite with one press of run button. That's it. Next one is easily execution of lengthy and complicated test cases. This is very important. Okay, and how there is a very lengthy test case and you know all the test scenarios, all the testing features are divided into different priorities like high priority, medium priority, and low priority. Okay, and we come to know all these things in the later sessions, don't worry. Okay, first, which features are very important to run the test suite, and which features are medium status, and which features are very low priority test cases. So by using that analysis, we perform testing. So commonly high priority features are very lengthy and very important also, friends. Okay, so that is why these complex calculative test cases and very lengthy test cases, okay, they will be automated first. Why? Because if we automate to those test cases, it will be easy to execute those test cases at every release and at every build. So the next important, fast development and fast delivery. Yes, exactly. So if we go with the automation testing, so the testing process will be speed up with the speed of XX or XXX. Okay, so then automation, the testing process will be done with a short period of time. At the same time, the development team also fix the defects with the same speed. Then we can deliver the project or product to the customer within the prescribed time span. Okay, and the finally is consistency. So sometimes whenever humans make testing, they may cause different types of errors. Okay, so but here when the test cases are automated, so consistency will be what is that, carried on. Okay, so like that, these are the important things. Why do we go for automation testing, friends? The next important thing I would like to share with you as a part of this video is principles of testing. Okay, there are two organizations which decide principles of testing. Those are, the first one is IEEE, the second one is ISO. These two organizations, non-profit organizations, decides what are the principles, what are the standards for software testing. Okay, so IEEE means Institute of Electrical and Electronics Engineers, and ISO we know very well. It declares all the standards for different goods and services, right? So that is International Organization for Standardization. Okay, and these two organizations prepared 7 incredible principles for software testing. We must, every software tester, every software testing company should follow these 7 incredible principles. Okay, so what are those 7 testing principles? Now let us going to see the first principle, that is, testing shows the presence of defects. Okay, so see here, even though the project or product is tested after the development, we cannot give the assurance that the developed project or product is 100% bug free. We cannot say that. Okay, so even though we tested all the features with great intensity, there may be chance of missing some bugs. Okay, so we cannot assure that the developed project is 100% bug free, but mostly we can assure that mostly this product is assured for less bugs. That's it. Okay, so testing shows presence of defects, not the absence of defects. We cannot say even after testing also that the defects or bugs are not present. Okay, they are they are not they are present, that's it. They are not absent. We cannot assure that. This is the first principle. And if you come to the second principle, that is, exhaustive testing is impossible. Okay, we cannot test exhaustively a product. That means what? Exhaustive testing in the sense, okay, all the features, all the possible features can be tested. Okay, for example, simple, I'll give you one small example that there is a password field. We have to test whether the password field is working properly or not. That particular password field has the combination of alpha numeric. That means what? Alpha characters in the sense what? Alphabets, along with at least one numeric characters, and the maximum length of that password field is 7 or 8 characters. That's it. To test this, there may be possibilities with one alphabet and remaining 7 letters or 6 letters are numerics, and 2 alphabets and remaining all the letters are numerics, and all the letters are alphabet and with one numeric letter, and lowercase, uppercase. With all these combinations, if you want to test the password field, there may be approximately 67 to the power of 7. Okay, so that large number of possibilities will come. Okay, 67 power of 7. Okay, so it is highly impossible to test all the features, all the possibilities. So that's why exhaustive testing is not possible. So we choose the major areas where those are called what? Bug prone areas, defect prone areas, where the errors, the defects may cause and obstruct the system running. So those important modules will be selected and they will be tested first. Okay, the next third important principle of 7 principles is early testing. So we have to start testing in the early stages of software development. So once the code is written, if you start testing, it will increase the cost and time consuming, right? So that's why software testing should be started in the early days. That means what? When the business owner, product owner gives his requirements, we have to prepare some documentation for that requirements. So that even documentation also should be tested with consulting the product owner, whether the prepared documentation is right or wrong. If the documentation is wrong, the entire development process will be wrong. So that's why if you test the documentation in the beginning days, so then there will be less number of defects or making errors in the upcoming development of the software or product, right? Okay, that is the third principle. The testing process should be started in the early days. And the fourth important principle is defects clustering. Okay, that means what? If the product is 100% consisting different modules, all the modules are not defect prone modules, right? Some important modules will be there according to IEEE norms. So if there are 100 modules in a project, in that project only around 20% of modules may cause 80% of defects. Okay, that means what? Remaining modules are normally not defect prone modules. Mostly few modules may disturb the smooth running of the software or product. So that's why we have to find out which module is highly defect prone, which module is low defect prone. So that is called what? Defect clustering. Okay, instead of scattering the defects, we have to make all the modules like a cluster, and we have to decide which module is highly defect prone. So if we test those modules first, we can save the time and cost for the production of the software, development of the software, right? Then next, fifth important principle is pesticide paradox. See, if we prepared some test cases, if the test cases run again and again for the longer time, they may not find defects. Okay, so that is the reason for at least 2 or 3 releases we have to make couple of modifications in the test suite. Then only we can identify large number of defects and bugs. So that's why we can assure the customer that there are very less number of bugs in this delivered project. Okay, right. The next last but one least is the sixth principle, that is testing is context developed dependent. Okay, context dependent in the sense what? For example, we are working with the e-commerce project. The testing process is different. When we are working with a banking project, the testing process is different. So that means what? Entire testing process depends on the type of business, type of domain what we are working with. Okay, so that is the reason testing, software testing depends on context. Okay, the domain dependent. Okay, so that is the sixth principle. And the last and the most important principle is absence of error fallacy. So absence of error fallacy is nothing but we cannot, in the beginning we discussed that testing shows presence of defects, not absence of defects. We cannot assure the customer that defects are absent. There is no defect in this project. We cannot assure like that. So there are, even though the entire developed project is tested, there may be chance of defects, 1 or 2 defects at least. Okay, so that's why absence of errors fallacy. Okay, that means what? We can assure only we are delivering the project with less number of errors, defects. That's it. Okay, these are important 7 principles for software testing. So here, my dear friends, if you wanted to crack your interview, you have to clear about what are the major principles of software testing. Okay, and for this you can take this screen as a screenshot and keep it as a wallpaper to your system, or note down and keep it somewhere else where you usually have a look. Okay, then you can easily remember these 7 principles of software testing, and whenever you are asked a question in your interview room, you can confidently answer. Then you can grab the interviewer's attention. Right. Then next, if you have any doubt regarding this 7 principles and the major modes of testing, just convey your doubts. Ask your doubts in the comment section. I am very happy to interact with you there itself. Okay, hope you contact with me there itself. Then next, introduction to different types of testing. In this particular video, I am giving you the briefing for the different types of software testing. In the next coming videos, I am going to discuss all the different types of testing in Clio. Okay, now this is a flow chart for different types of software testing, friends. Okay, so there are 2 types of modes of software testing. Already we discussed in the beginning of this video and in the previous video also, that is manual testing and automation testing. And this manual testing or automation testing, whatever it may be, they will be like this. These manual testing is divided into 3 categories, like white box, black box and gray box. Okay, simply we can say that white box testing means where this testing is also called as a transparent testing, where the code is transparent to others. The tester can see the code, internal code, background code, the development code is visible to the tester. So who can commonly see that code? Developer. So this test is done by the developer at the level of unit testing. We'll discuss. Okay, these terminologies may be new for you. Okay, don't worry, but don't worry. In the coming sessions, we discuss each and every point in clear. Okay. So this white box testing is done by the developer itself. Okay, and he tests the syntax of the code writing and some inputs and how the code is responding in the form of output. Okay, so this is called what? White box testing. This also, remember this. So some interviewers may ask, what is transparent box testing? Don't confuse. Okay, so transparent box in the sense what? White box. What is inside, it is visible, then only it is called transparent. Okay, what is inside the developed project? Simply development code. So if the code is visible, that is transparent box. Okay, the next, black box testing. So all the QA team, that means what? We, the testers, will done black box testing. Okay, there the box is black. Okay, that means what? We cannot see the code. Just we can work on out screen only. That is why it is called black box testing. Okay, whatever the QA team works on, that is called black box testing. How the system, how the software is responding when we perform some actions with the software, how it is responding. Just we check that. That is called what? Black box testing. And commonly most of the people will speak about this white box and black box only, and gray box is a little bit that means what? Commonly it is avoidable. Why? Because gray box is nothing but what? It is a combination of white box and a black box. Okay, it is the integration part of white box and the black box. So that's why separately we need not to explain about that gray box testing. Okay, the next, this black box testing is divided into two categories, like functional testing and non-functional testing. And what is functional testing? The functionalities are tested. Non-functional testing, non-functionalities are tested. What are the non-functionalities? Appearance. Okay, GUI testing. This is also called as what? GUI testing. Graphical user interface testing. Okay, user interface. How the interface is visible to the user, that will be tested. Okay, that's it. Okay, and functional testing is divided into again three important categories, like unit testing, integration testing, and system testing. Then next, this integration part will be divided into two modules, that is incremental testing and non-incremental testing. And this incremental testing is mostly done in two ways, that is top down and bottom up. These are the two important ways to conduct incremental testing. In the non-incremental testing, we need not to worry about the development, how the flow is. Okay, so we can carry out the non-incremental testing with our test plan. That's it. And non-functional testing is very important testing. Functional testing is important, and as well as non-functional testing is also important. How this non-functional testing is done? So this is done in three levels. One is performance testing. How the performance of the software is in different scenarios. Okay, and usability testing. How it is applicable when the user is applying his efforts with how the user is contacting with the software or application, whether it is user friendly or it is not interactable to the user so easily. So we have to test that. Okay, and compatibility testing is also. Compatibility testing in the sense, if one software is developed that will be apt for Windows, that means what? Multi operating systems, whether it supports multi operating systems like Windows and Mac operating system and Linux, Unix, different operating systems will be there. So whether the developed product is can be run in multiple platforms or not, and whether the developed web project is run in Chrome, different browsers like Chrome, Firefox, Safari, and other browsers. Okay, so whether the developed project is fit, suitable for different operating systems and different browsers and different devices like laptop, desktop. Okay, so all these things will be tested. That is called what? Compatibility testing. And again, performance testing is divided done in different levels. That is load testing. When n number of users access to the same application at one time, how it is handling the load. See, sometimes some applications are cracks. Okay, they will be crashed because of high load. The best example for this is we can say that the highly reputed government's website, okay, is crashed only because of this load testing. Okay, it was not able to bear that high load. That is Dharani portal. Okay, we can easily understand. When all the users accessed that Dharani portal at a time, it is a prestigious portal actually. But when number of users accessed that portal at a time, it crashed. So that's why that portal showed some errors. It took a lot of time to load. Now it is refined again, reconstructed again. Okay, so that's why we, before releasing the product into the market, we have to testing how the project handles the load. That is very important. And stress testing. Stress in the sense what? If any application works for a longer time, okay, some applications, if we use the same application for 3 hours, 4 hours continuously, it strucks. Okay, so how it handles long period of time running. Okay, that is called what? Stress testing. And scalability testing. Okay, scalability testing in the sense what? How the success of testing, success of application, how far it is meeting the requirement. That is called what? Scalability. And stability, how a number of what is that, applications are opened. So but the always, even n number of times, just I open and close the application, open and close the application, open and close the application, n number of cache and cookies will be downloaded. Though the system should work properly, the software should work properly. That is called what? Stability. So for all these testings, for all these different types of testing we conduct, whether the project is successful or not. And in these areas, we can automate almost all the scenarios, all different types of test cases we can prepare and run automatically. But we can use automation, but few things will be there. Okay, in graphical user interface, usability testing will be there. Okay, and that means what? How the application is user friendly. Okay, so we cannot automate it, right? Okay, why? Because our system is not a user, it is not a human being. Okay, how the application is friendly to us, we can observe by looking at it, right? So that is the reason few areas cannot be automated, they should be tested manually. That's it. Okay, so like this different types of testings are there. We discuss all these testing types in brief in the upcoming videos, but take a screenshot of this particular flowchart of types of testing and keep it somewhere where you have a constant and frequent look. Okay, then you can remember all these things in surety. Okay, and these are very important for your interview room. So this is today's session, and I hope it is clear for you. And if it is not clear, why? Because it is a completely theoretical path and it helps you to answer the questions in a fluent way and confidently in the interview. So please note all the points, and once again, if it is not clear, once again watch the video from the beginning and note down each and every point what you feel important. If you have still any doubts, please comment. I'll be happy to interact with you there. Some of you are watching the video without subscribing the channel, so it is supportive to me if you subscribe the channel. It is very motivated to me, and please subscribe the channel and please share it and like the video. Thank you all.